Yes, hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. Our discussion today, I'm going to look at an evaluation which is basically going to consider the relationship between potential energy, kinetic energy, and work. And this is going to be in form of this illustration which I've given on my left side of the board. Now we're going to see how we can express particularly some aspect of force, perhaps a velocity, and other concepts which we have learned in these three specific aspects. And of course, we are going to see how we can generally try to represent this specific, of course, a kind of perhaps a velocity, force, and the work which I've mentioned in our last part. Now, in this case, we're going to consider this specific object that consists of a mass m. And this object is going to be dropped from the top of a building which is of a height m in h in terms of meters. And of course, we're going to see that in consideration of this, this is going to be forming the ground level, and this is going to be the top part of the building using this particular illustration. Now, we are required to show that the speed of the object when it's at this specific position, of course, is going to be given using a particular formula. Now, in this case, I'm just going to quote this so that we can do a follow-up. So, we are required to show that the speed at this specific position, which is y meters from the ground, is given in terms of v, of course, which is going to form a v final. Let's assume that the initial velocity from this specific building was 0. So we're going to see that we're required to show that this specific position, the velocity is equivalent to the root of 2g, and then h minus y. So in this case, we're going to have where it is this going to be the gravitational constant which we normally give in terms of y, and of course vf is going to be the final velocity or speed which we have mentioned in this particular case. Therefore, in order for us to evaluate this specific one, we're going to use various concepts which we have learned from our previous discussion, which are going to assist us in trying to define this. So at this specific point, we said we are going to consider the potential energy of this specific object and the kinetic energy of this specific object given as such. Now we're going to see that we had learned various aspects from the work energy theorem in our last discussion, various topics which basically dealt with the potential energy, kinetic energy, and the work. So at this specific point at the height of y, we're going to see that at y, the potential energy of this specific object is equivalent to the kinetic energy. And from various discussions which we have learned, then therefore we're going to have this relationship holding. So therefore we are going to consider the displacement in terms of d from the ground equivalent to y. And therefore, in case we use this n of these initials in our evaluation, it's going to mean about the same thing. Therefore, we can give this one in terms of the potential energy or the kinetic energy given in terms of so we're going to have the potential energy given in terms of the product of mass, the gravitational, of course, constant given as such times the distance. And in our case here, we have mentioned that our distance is going to be forming this specific aspect of y. So the kinetic energy as well, this specific point, which two factors, which of the two factors are, whereby the two factors are constant, is given as half mv squared, whereby we're going to consider the mass of this specific object and the velocity, the square of the velocity, given as this. So we have stated that at this specific point, whereby at this specific point where the two factors are going to be constant, therefore it will be okay for us to equate these specific sections of the two equations on right side being the same, whereby we're going to have mv squared all over 2, which is for potential energy, for kinetic energy is equivalent to m. So this is going to be a negative value which we had decided from the work aspect from our last discussion on the concept of gravitational and elastic potential, particularly gravitational potential. Therefore, we are going to have this one as negative m g y. So I said that this basically is going to be defining our aspect for that particular y. So a further evaluation of this specific equation is going to give us, of course, we're going to go slow. So this is going to be mv squared is equivalent to the negative value of mgy times 2 from this specific case. and therefore further referring to the product of velocity squared given as negative value of 2gy. And if we try to look at this one, the y which we have given in terms of the gravitational constant is going to be a positive value, but the difference in distance which we have given in terms of y is going to be, so perhaps let's try to give this one in terms of, we can give this one in terms of y prime. So y prime can be defined using this specific of, or rather, let's have this one as a displacement from this one to this one. So we can give this one in form of a y prime. So let's consider this one. So y prime can be defined as h minus y given as such. So I'm going to consider this one as the displacement which is going to be given in terms of a y prime given as such. So this is going to be forming our y prime, which is basically going to be the displacement. So this is not going to be, so we are going to do this adjustment whereby the difference between h and y are going to give us what we refer to as a d, which is going to be our displacement. So this is going to be referred to as y prime, so that we can have that specific clarity from there. So we're going to have this one given in terms of half mv squared, which is going to be the product of a negative, the product of a mty prime given as such. So we're going to carry on this one given as such to create that difference. So at that specific point, we can define this one and say that where y prime is equivalent to h minus y. And then we're going to see that for us to find the value of this specific equation, we can do a substitution and have negative 2y, 2g into h minus y given as that one. And of course, as we said, this specific change in a positive direction is going to be a positive, and therefore we are going to have that negative sign given as such. So therefore, that's going to result in this specific equation, and therefore we are going to see that, so this is in consideration of the fact that g is going to be going in that specific positive direction, and therefore we are going to have this specific aspect of velocity as the root of 2g into h minus y, which is going to form our final part of this specific representation for velocity. Now, in this case, this is going to be a task that was required for us to show that basically the velocity which is going to be described by this specific motion at this particular point is going to be given in this specific format. So in this case, we're going to use various aspects. One of them which I've defined at this specific point is potential energy at this specific point along each path is going to be equivalent to the, of course, kinetic energy. And we're going to do a substitution for these two specific aspects which I've mentioned. Now, from that specific illustration, then therefore, I say that we're going to consider this particular aspect of our work from the previous discussion we had on the gravitational potential, whereby we defined that the work done is going to be at the negative value of the force times displacement, which of course is given. So in consideration of the fact that we're going to have this gravitational constant, which is going to be positive, and of course we're going to see that this distance can be given in terms of the difference between the whole distance and the height from the ground, of course, which is going to be giving us y prime. Now in this case, we're going to do a substitution for this, whereby we're going to see that the y prime in this case, or in this case, is going to be given as h minus y, and therefore that's going to result in our final representation for this specific evaluation. So that's going to be giving us an aspect of a relationship between the potential kinetic and work, and of course, among others, which we are going to do in a subsequent videos. They are going to shed light on us on the relationship which is going to exist between the three aspects. So that is it for now, guys. By God bless you. Catch us in our next video.